Thank you for the introduction. Oh, okay. I will share my screen. Let's see if it... okay, you see it? Or...
Yes, perfect.
Okay, great. So, I mean, given the topic of the group, I thought I will just present kind of the text reuse approach and like the method I use in this paper more than like the application itself. But I mean, I'm sure I'm open to talking about it, of course, in the Q&A afterwards and all of that. Okay, so as Clint mentioned, what I'm trying to do in this paper, my kind of substantive interest, why I'm interested in this text reuse approach in the first place is because I want to measure interest group influence on parties and specifically on their kind of positions on specific policy proposals. And measuring interest group influence just in general is kind of difficult. I mean, there's a lot of difficult things to measure in political science, but this is one of them. So I really like this quote by these great interest group researchers. So yeah, it's just like a difficult thing to measure this interest group influence concept. And I wasn't really kind of the traditional approaches or kind of the existing ways of measuring interest group influence, they weren't exactly what I was looking for. So then I remembered that I had read this paper by Wilkerson et al., which was published, I think, in like 2015 or something in AJPS. And they look at kind of how legislators use the kind of same language in different bills. So kind of how these policies, ideas are reused across like legislation. So I was thinking, okay, maybe I can use this for my research and measuring interest group influence. So just in general, there are like two main approaches when it comes to text reuse. So it's like global and local alignment. So with global alignment, the question is kind of how similar are two text documents overall? So the question is kind of, the global alignment, as the name says, but it's like similar to kind of plagiarism tools and stuff like that. So here you look at two text documents in general, overall similarity. And the local alignment approach is one where you are interested in kind of detecting the most similar sequence of words within two texts. So you look at like, given these two texts, what is the most similar sentences or whatever within these two texts? So it's more specific, hands-on, kind of concrete, what you get out of this approach. So I was interested in the second one and using it to measure interest group influence. So the question I asked basically is, do political parties copy input from interest groups? So this is kind of interest group influence on the substantive content of parties' positions on policy proposals. So I argue that there are several kind of pros with this approach compared to these other methods. And I just wanted to mention them briefly. So this is like, doesn't really rely on the actor's perception. So one common approach is to interview or to do surveys of either interest groups or like legislators, whatever. And another pro with this approach is that there are ways to kind of ascertain that the input that the party reuses or another kind of legislator or whatever originates from the interest group in question. I will come back to that briefly. And another kind of common approach in the interest group influence measure world is to look at kind of the overall similarity and see like whether a party or a piece of legislation moves closer to the interest group's position, for instance. So you look at, again, like this kind of overall document or position, but it's like with this like as this quote says, it's possible to imagine a scenario where you kind of the interest group has influence on one specific part, and that might not be detected the same way. But with this kind of local alignment approach, you get this very specific, like concrete, output. And lastly, it also enables analysis of like a large number of actors, policy proposals, and so on. So this is perfect for my purposes because I was interested in looking at kind of variation at the issue level and so on. So I needed it's like more than one policy proposal in a way. So yes. So the data I use, the text data I use for political parties, it's their parliamentary speeches and the amendments they make in the parliamentary committees that like MPs are members of. So that is like, I merged these two together. And for interest groups, I look at their submissions to government consultations. So these are like, the government organizes a like hearing for interested parties or interested actors, and it's open for everyone, and whoever is interested can like submit their comments on this proposed policy. So I look at these submissions. And I look at this in Norway between 2005 and 2015, mainly for practical purposes, like when is these types of texts available. So this means that I look at 8 parties in total, 7 for the whole period, and like a bit over 1,700 unique interest groups have submitted at least one submission to this government consultation. And I look at 88 policy proposals. So I get a substantial amount of like these policy proposals. But again, like these are policy proposals where the government has organized a consultation. So it's not like a random sample. So that's the texts I use. And so I use this specific algorithm. I think this is the most common one, maybe in this local alignment world. So this algorithm locates the optimal matching subset. So in my case, it's for a given party and interest group document. So the speeches and the committee amendments for the party and the government consultation submissions for the interest group. And this algorithm compares these documents word for word and locates the best match. So there are kind of 3 parameters that you have to define with this algorithm. So it's like score for a word match, and then penalties for mismatches and for opening a gap in this like sequence. So the specifications I use is like a score of 5, which I think is kind of the standard, at least if I remember correctly. And I use the least punishing score for the penalties. And the reason for this is like this matching, this word match score, it makes the kind of matches that I get more succinct. So if I had chosen different specifications, I tried some different specifications and I got like super long text where it's like, it's kind of hard to see like, what is this? And the least punishing score is to kind of allow for variation, like that the party has changed some words and so on. So I also checked that like, will instances of text reuse actually be detected if I use the specifications I run like it's kind of ipsum lorem text or whatever it's called, like just standard text, and see like tried out different specifications, and it did detect these matches. So I think it's like fine to use these specifications. Okay, so I also wanted to show you like just like what does look like in R, which I used for this purpose. And I mean, it's kind of embarrassing to share this because like I'm sure that my code is horrible looking, but so I just wanted to say that it's very straightforward. And so just like if you have like kind of nice looking text documents, you don't need to do a lot of text pre-processing, which is fine. Like this a nice like bonus with this approach. Like you don't need to do a lot of like removing common words and all of that. So just import the text documents, and then I save them as like objects in our whatever. So very straightforward. And so this is an example of like just I use this align local. What is called, like, you know what it is, this align local thing. Like this is the interest group document, this is the party document, etc. And this is like what the output looks like. So as you can see, I get this like alignment score. So this is like the score that the algorithm gives you. And what I was interested in is like, can this score tell me something? So in this case, like I can see that it's like, this is an example of a substantive, like the party in this case is kind of a substantive argument from an interest group. But in some cases it might not be substantive. So this is an example where the interest group and the party just says like, we think it's important that, and it's like, this is not what I'm interested in capturing. So I'm interested in these like substantive ideas. And as you can see in this case, like this score is 25, and in this case it's 466. So it's interested in like, when can this score tell me anything? Can I use it to automate the process, you know? So I randomly selected 10 of my proposals and coded, like went through all of the matches, coded, is this a substantive argument? Is this not a substantive argument? And what I find is that like below like 30-ish, a score of 30, there's like basically no substantive arguments that are captured. And if you score more than 30, sometimes it's not substantive, but other times it is. So that's like what I used to kind of semi-automate this approach. So for the remaining 78 proposals, I just assumed that all of the matches that had this score of less than 30 were non-substantive matches, that they didn't reflect any substantive arguments, they didn't reflect any substantive ideas. And then I manually checked the remaining matches and saw like, is this a substantive idea? Keep it. If it's not, I remove the or the text in question, run the algorithm again. If it's below 30, I throw it out, and then like if it's not, I keep it, and then I do this process until it's like either below 30, blah blah blah. Yes. So what I wanted also to mention in this with this is that a kind of main issue here was that a lot of the times the party and the interest group would copy, or they would like quote directly from the policy proposal. So this was the main issue with this kind of, when I checked these remaining matches, a lot of the times the substantive ones that I weren't interested in were cases where the party and the interest group had, where they quote from the policy proposal text. So if I were to do this again, I would probably try to find like run the policy proposal text against the documents I'm interested in and removing that from the start, maybe, I don't know. But that was the main kind of stuff I weren't interested in that I had to like go through. Yes, and as I mentioned before, I tried to ascertain that the text originates from the interest group and not from some other actor or whatever. So I check like, does the party credit someone else with this idea, and I Google it and all of that. So I tried to kind of make sure that this is, or as far as possible, that it comes from the interest group. Okay. Last slide. So my dependent variable that I end up with, I find kind of 698 instances where a party copies like some substantive idea that originates from an interest group. And this is the case for 59% of the policy proposals I look at. And again, this is like not a random sample, it's like policy proposals where the government has organized these consultations. But again, like it's not like super rare, it happens fairly frequently. And the dependent variable I end up using is just like the number of words like that a party actually copies. And the reason for this is that the score that I mentioned would be a different, like another operationalization I could have used. But I think like it takes in the length of the documents into account somehow. So I was like, maybe the number of words is more comparable across documents. So that's what I ended up using. So, I mean, here we have all the different parties. And if we exclude the cases where they don't listen to anyone, it's a fairly similar like number of words that they typically copy. Yeah, so it's kind of similar across parties. Some parties I don't have that many observations for, but anyways, it's something that all of the parties in Norway, like all of them do this kind of reuse of interest group input. So it's not like exclusive for like specific parties. Okay, that was what I wanted to say. That was my presentation.
Thank you so much.
I don't know if I should like stop sharing.
Yes. Thanks a lot for this excellent presentation and for kicking off this this session. I guess many people